Algebra Honors Unit 6 is our unit on exponents and radicals. This is our day 5 set of notes with a quick warm-up. So our last lesson we were simplifying radicals where we were just simplifying square roots. So remember, if you have a radical symbol with no number in that index spot, you assume that it's a 2. You're looking for the square root. So when I'm looking for the square root of 700, I can either find a factor tree for this, or I can try to think of perfect squares that are factors of 700. So for me, in my mind, 700 is 7 times 100. I'm choosing those numbers because I know 7 times 100 is 700, and this is a perfect square, 10 times 10. As soon as I see that I have a pair of numbers, the exact same thing twice, I know that that's what I'm going to pull out of my radical sign. So I'm just going to show you, this would be 7 times 10 times 10, or I know that the square root of 700 equals the square root of 7 times the square root of 100. Remember, we said that we can break up our radicand into factors, and then we can split them apart like that. I'm choosing this because I know this equals the square root of 7 times 10. The square root of 100 is 10. And so I'm going to rearrange that because mathematicians like to have things look different. We want our number that's not in the radical on the outside. 10 times the square root of 7 is my final answer. Okay, when I was doing a factor tree, you can see that I had a pair of 10s. I would have pulled out one of those 10s to the outside of the radical, and I would have kept my 7 inside the radical since 7 didn't have any buddies to go outside and play with. All right, so I'm going to similarly do square root of 50. I know that is the square root of 25 times 2, which is the square root of 25 times the square root of 2, which is square root of 25 is 5 times the square root of 2. Just by the way that I organized that one as I was writing it down, I didn't have to switch the order. I didn't have to rearrange anything. Okay, square root of 128. Well, let's see, 64 is a perfect square. So I think to myself a lot about what are the perfect squares I know that might go in here. Well, 64, I'm going to say that this 128 is the same as 64 times 2, right? I'm just thinking of perfect squares that I can divide into my radicand evenly. So luckily that means square root of 64 times the square root of 2, and so I get 8 times the square root of 2, or 8 radical 2. Okay, if I solve this one, I'm going to solve this one a separate way. I'm going to solve it using a factor tree. Okay, so I better get the same answer, right? So I want the square root of 128. So I know that I have 2 times 64. This is prime, so it stays. This is going to be 2 times 32. That's prime, so it stays. This is 2 times 16. That stays. This is 2 times 8. Okay, anytime I have a prime number, I'm taking it out and circling it, right? So 2 times 4, prime, and 2. All right, so I know that 128 equals 2 times 2 times 2 times 2 times 2 times 2. So if I pull out pairs, that's a pair right there, that's a pair right there, that's a pair right there, and this guy is not a pair, so we're going to leave him in the house, right? He doesn't get to come out because he doesn't have any friends to play with. So here's my radical. 2 is going to stay inside. Okay, but I'm going to take out this pair of 2's, and once they leave the house, they have to stay together, right? So I'm going to say that outside of the house, the square root of 2 times 2 is just 2. Okay, that's that one. Now, these guys also come out. So the square root of 2 times 2 is 2. And these guys come out, so the square root of 2 times 2 is 2 there. Okay, so when I pull a pair out from underneath the radicand, it effectively looks like a singleton. So I had all of these guys still multiplied together, right? All of this, 2 times 2 times 2 times 2 times 2 times 2 times 2 is 128, so I'm multiplying. There's lots of multiplying going on. 2 times 2 times 2 is 8, times the square root of 2 is my answer. And that is what we got when we figured out a perfect square that was a factor. Okay, so it is up to you how you do it. And sometimes, even if it's something simple where the perfect square is 64, if you just didn't see it when you were working on a quiz or a test or a homework, it's okay to do that out by the factor tree. Square root of 63, I'm thinking about factors. I know 63 is 3 times 21. Those aren't perfect squares, so this is yet another way to look at it. 4 does not go in, 5 doesn't, 6 doesn't, 7 does, 7 times 9. Ooh, I like that, because 9 is a perfect square, right? So I'm going to rewrite this as the square root of 7 times 9, which is the square root of 7 times the square root of 9. I did that because I know the square root of 9. So I have the square root of 7 times 3, and I'm going to rearrange that so that I have my number all by itself in the front, times the square root of 7. And that is my answer. Okay, so those are ways to simplify, and it's several different methods that I've chosen to show you here. It's important that you get the correct answer. It is not important that you choose the same exact method as me. So go with what makes sense to you. That was our warm-up, so that's what we did last lesson. We simplified radicals when we were talking about square roots. So today we're going to simplify radicals when we're talking about cube roots. So remember, a cube root is something to the power of 3. So a square root, remember when we said you might have a perfect square, that is 3 by 3, right? That is a square, a perfect square of 3 times 3, which is 9. If I have a cube, it's going to actually have 3 dimensions, right? This has 2 dimensions, a length and a width. Here I have 3 dimensions. So I might have 3, I might have 3 as my height, and I might have 3 in this direction. So 3 cubed is 27. Okay, and I'm not going to draw all these little boxes because that would be a giant mess, but that's why we call it cube. That's why we call it square. We make a square or we make a cube. All right, so let's, like we did with our squares, our perfect squares, write out your perfect cubes. So start with me. This means 1 times 1 times 1, which is just 1. This means 2 times 2 times 2, which is 4 times 2, which is 8. And this is 3 times 3 times 3, which is 27. So pause the video, write out these perfect cubes, and then come back and just make sure you've got everything right. All right, so if you cube each of these integers, or they're also whole numbers because none of them happens to be negative, if you cube each one of these numbers, you're going to get an answer which is a perfect cube. That's because if I take the cube root of it, I will have 3 factors that are exactly the same, and they are integers. Okay, so taking the cube root of a number is the opposite of cubing it. So if I take the cube root of 64, what I'm asking is, what can I multiply by itself 3 times? Remember, that's called the index, that 3. What can I multiply by itself 3 times that's going to give me 64? Okay, so most of the time when we give you problems, we're going to give you something that is a perfect cube, or it's a factor. A perfect cube is a factor. And so it might be 64 times 2, so that you can pull that perfect cube out. So just know that. If you kind of write down on the side of your paper some perfect cubes, you can just have them in the back of your mind when you're working. All right. The cube root of 64 equals 4, and that's because 4 cubed equals 64. Okay, 4 cubed equals 64. The cube root of 64 is 4. All right, and on a side note, if I asked you for the 4th root, see my index is 4 there. If I asked you for the 4th root of something like 16, I want to know what times itself 4 times gives me 16. This one I happen to know is 2, right? Because 2 to the 4th power equals 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, so the fourth root of 16 is 2. And we can do fifth root and sixth root and all kinds of crazy things. For this class, we're going to stick with square root and cube root, but just wanted to point out that our index can be, for us, any whole number or any... I think it's going to be any whole number. It's going to be any natural number anyway. I think it's going to be a positive number, 1, 2, 3, 4, and so on. Okay. So again, we're going to use these two rules that we used when we were talking about factoring square roots, right? So if I can tell you that the square root of a times b under the radical is the same as the square root of a times the square root of b, I'm going to extend that out and say that the cubed root of a times b under the radical equals the cubed root of a times the cubed root of b. And that's just helpful because we can split things up to find perfect cubes. Okay, if I'm using the product rule, what I'm really trying to do is break up my radicand into factors where one of the factors is a perfect cube this time, since I'm looking for cube roots. Okay, so I'm looking down here at the cube root of 24, and I think, what are the factors of 24? Here's what I can do to get to 24. Obviously 1 times 24, but that doesn't help me because 24 is not a perfect cube, right? 2 times 12 is 24. These are both not perfect cubes, so that doesn't really help me. 3 times 8, ooh, I like that because 8 is a perfect cube. This is why, I'm going to flip my paper, this is why it's helpful to be thinking in your head of what are perfect cubes. Look, 8 is a perfect cube. That means I can take the cube root of it. So I'm flipping my paper again. So if I have the cube root of 24, I can rewrite it as the cube root of 8 times 3 and split that up. So it's the cube root of 8 times the cube root of 3. And this I can simplify. The cube root of 8 is 2. And so that's how I get 2 times the cube root of 3. Okay, if I'm using my prime factorization method, I'm just going to keep dividing whatever number I have into factors. Okay, and the truth of the matter is it doesn't matter what you start dividing by, because you will end up with all the same prime factors in the end. Since it's even, I usually start by dividing by 2. So 24 is 2 times 12. Okay, 2 is prime, so we're going to hang out there. 12 is 2 times 6, and 2 is prime. So 6 I can break up, it's 2 times 3. 2 is prime, and 3 is prime. Okay, we want a cube root of this number. So instead of a pair, or last lesson rather, we were looking at pairs of numbers to pull out. I'm looking for a triple. Womp, womp, womp. I have 3 2s. So when they go out to play now, they have to be in groups of 3. So I'm pulling a group of 3 out. So I'm going to have 2 on the outside of the house. And then inside, this remaining 3 did not have 2 other friends to go outside with, so that remaining 3 stays inside. So my answer is 2 times the cube root of, oops, you can't see what I just did, sorry. I circled that or boxed that. 2 times the cube root of 3. Okay, either way is completely fine. Probably for cube roots, actually probably for square roots too, for radicals. In general, I'm going to look for perfect squares or perfect cubes when I'm simplifying. All right, so I know 48 is 2 times 24. I need the cube root of 48, so I'm looking for, oh, you can't see that, I'm sorry. 48 is 2 times 24, so I'm looking for perfect cubes. No perfect cubes there, right? 3 goes into 48, 3 times 16, not a perfect cube though. 4 goes into 48 12 times, still not a perfect cube there. 6 times 8, ooh, I like that guy. 6 times 8 is 48, and I see a perfect cube, yeah? So, you don't necessarily need to write these all down. I just wanted to write them so you can see my mental process. I was figuring out factors of 48 until I found one that had a perfect cube. So I'm going to say, and I'm going to write this as 8 times 6. Strategically, I'm putting my perfect cube first. Okay, 8 times 6 is 48, so I can write that as this cube root of 8 times 6 under the radical, which is the cube root of 8 times the cube root of 6. And I know the cube root of 8 is 2, so that's going to be 2 times the cube root of 6, just like that. All right, so 216, I know is that maybe a perfect square, or it's 2 times 2 times 2, a whole bunch of 2's. I'm going to look and see. Oh, it's a perfect cube all by itself. It is 6 cubed. Nice. So if I wrote down a bunch of perfect cubes, I know already that this is the cube root of 216. Sorry, I don't know why I rewrote it. Equals 6. Okay, on your calculator, here's how we're going to do this if we want to see if it's a cube root, perfect cube. You're going to turn on your calculator, clear it, put in 216, okay? If I want to know the cube root of 216, I'm going to use my second function. So I'm going to use one of these upper pieces of information that's above one of these buttons. So we have a button that says cube root. So the 0, if you were to look, that really does say cube root of x. So I put in 216. I'm going to say second function, and I'm going to press the 0 button because it's going to give me that second function information. When I do that, it found the cube root of 6. Okay, so your instructions there were type in 216, press the second function button, which is either yellow or green on the school computers, and then you're going to press the 0 because above the 0 it says cube root of x. Okay, and it will pop out the answer 6 that you're looking for. All right, 432. I don't think that's going to be a perfect cube. Nope, I go from 216 to 343. But 216, is 432 divisible by 216? Can that be one of the factors? Let's see. 432 divided by 216 is 2. Hooray! So since I know 216 is a perfect cube, I'm going to say that here I have the cube root of 216 times 2, right? I'm doing that because I know 216 is a perfect cube, because now I'm going to say the cube root of 216 times the cube root of 2. We just said that the cube root of 216 is 6, so I know it's 6 times the cube root of 2. Make sure that when you're putting your answers, if you're using cube roots, make sure you put that 3 in there, because otherwise you're asking for the square root, which is not the same thing at all. Okay. I'm going to stop the video here, and I'm going to do cube roots of negative numbers in a second video, just to give me and you a break.